Enjoy the Milky Way sight while it lasts. Can you find your city in this stunning image? You most likely live in a very light-polluted environment. Life on Earth has developed in unison with the natural cycles of light and darkness for over 3 billion years. The only sources of illumination have been the sun, moon, and stars, which have shaped the natural day-night cycle that has directed innumerable species. However, our modern cities have evolved into artificial light beacons that outnumber the darkness, breaking this delicate equilibrium and forever altering our environment. The repercussions of this major shift may appear intangible at first, but a growing body of evidence indicates the tangible and far-reaching detrimental effects of our lightened night sky. First and foremost, human health is at risk. Not only that, because of our lit cities, the ecosystem and wildlife are also suffering. Furthermore, our constant illumination of the night sky endangers stargazing and scientific study. If we do nothing, the Milky Way, a majestic phenomenon that has inspired awe and wonder for millennia, may soon vanish from our skies. Light pollution distorts our perception of the universe, impairing not only our ability to comprehend its grandeur but also our scientific comprehension of it. Hello and welcome to Zeey. Subscribe to our channel and ring the bell so you don't miss any of our daily video. Darkest versus most polluted regions. The composite image shown at the start of this film was made using data from the Suomi National Polar Orbiting Partnership satellite. This data was collected by the satellite over 9 days in April 2012 and 13 days in October 2012. To gain a clean and comprehensive view of the Earth's land surface and islands, 312 orbits and 2.5 gigabytes of data were required. The graphic shows that China, America, Japan, Europe and Egypt as well as the region between Qatar and Kuwait have the most extreme brightness. In 2018, Moscow was named the most light-polluted city, followed by Riyadh, Saudi Arabia and Montreal in Canada. Furthermore, it is clear that some places of the world have much lower amounts of light pollution than others. Australia, New Zealand, Africa and South America are among them. Nonetheless, keep in mind that the satellite image just represents one point of view. It provides a perspective of the Earth's surface from space. However, there are significant distinctions when looking up from the ground at the expanse of space. This begs the question of how the existence of light pollution affects our environment. Although the image depicts the breadth of pollution, it does not reflect the effects on the ground level. These can have negative repercussions. Montreal versus McKenzie Reserve. If you can't see a single star in this image, don't worry, it's not because you're blind. This image of Montreal at night demonstrates how light pollution can have a significant impact on the environment. Images like this serve as a harsh warning of the effects of light pollution on our environment. As humans continue to invent and innovate, we are responsible for the majority of environmental damage on Earth. Our inventions have had far-reaching impacts, from automotive emissions contributing to climate change to hazardous plastics filling our oceans. Among these inventions is the electric light bulb, which is often regarded as one of humanity's greatest triumphs. While technology has clearly benefited our lives by leading us home and creating a pleasant environment, it has also had an unforeseen consequence: light pollution. Excessive artificial lighting in cities obscures our perspective of the night sky, making it difficult, if not impossible, to appreciate the cosmos' majesty. Fortunately, there are still dark regions on the planet where the night sky is not polluted by light. The McKenzie Dark Sky Reserve in New Zealand is one such location, and it is the largest reserve of its sort in the Southern Hemisphere. This reserve, which spans the Mount Cook National Park and the McKenzie Basin, was formed to preserve the natural dark skies free of light pollution. From this remote spot, one can experience the Milky Way's stunning beauty like never before. Furthermore, being in the southern hemisphere allows you to see the Magellanic Clouds, two dwarf galaxies that orbit the Milky Way. Imagine being able to see two extragalactic objects with your own eyes at the same time, without the use of telescopes. Isn't it bizarre? Some people believe that if you have never seen the Milky Way from a location like this, you have not truly lived. In any event, how different is the Montreal sky from the Aoraki Reserve? Is it possible to calculate the disparity? Yes, it is a resounding yes. To quantify the degrees of light pollution in different places, many measurements and scientific methodologies can be used, providing for a quantitative comprehension of the contrast between the two skies. The Bortle scale is the most commonly used method. Bortle scale. The Bortle dark sky scale is a numerical scale that is used to determine the brightness of the night sky and stars at a certain location. It evaluates the visibility of celestial objects as well as the effects of light pollution and sky glow. It was created by John E. Bortle and released in 2001 to help amateur astronomers compare the darkness of different observation places. The scale runs from Class 1, the darkest skies on Earth, to Class 9, which represents inner-city skies. High Bortle scale scores indicate regions with high light pollution, making them the worst for stargazing. A Class 9 city, for example, will have a brightly lighted sky with few visible constellations, except for the moon, planets, and bright star clusters. Forget about the Milky Way, you won't even be able to imagine it. These conditions are frequent in the world's brightest cities. With a Class 5 rating, the Milky Way is faint or undetectable near the horizon and appears washed out immediately overhead. Most or all light sources can be seen and clouds will look brighter than the sky. The viewing experience improves as you travel down the scale from 5 to 1. For example, the Aoraki Reserve is assigned a Class 2 grade on the Bortle scale. The Andromeda Galaxy, as well as the Magellanic Clouds, can be seen with the naked eye from this location. The Milky Way is breathtaking, and the moon can even cast shadows at dusk. This provides spectators with a truly stunning sight. According to physicist Christopher Kaiba of the German Center for Geosciences, light pollution is rapidly brightening the night sky, with an alarming annual increase of around 10%. This alarming tendency offers a grave threat, as it has the ability to eliminate the visibility of all but the brightest stars within a lifetime. For example, a child born today in a place where 250 stars can be seen at night will only have a limited view of roughly 100 stars by the time they reach the age of 18. If these forecasts are correct, it is disheartening to think that the fascinating sight of the Milky Way may become invisible to human eyes as early as 2050. So enjoy it while it lasts. Alright, before continuing on, please let us know if you liked or disliked the video so that we can improve it for you, the viewer, and don't forget to subscribe to our channel by pressing the notification bell to ensure you don't miss any of our daily videos. Effects on birds' migration patterns. Of course, mankind used to illuminate their evenings with fire in ancient times. Things changed quickly after humanity discovered electricity, and many excellent things came with it. However, like with carbon dioxide emissions and plastic, too much of a good thing has begun to harm the ecosystem. Light pollution, or the excessive or inappropriate use of artificial light in the outdoors, has an impact on human health, wildlife behavior, and our ability to perceive stars and other celestial objects. To begin, light pollution has been shown to have a major impact on bird migration patterns. During their migrations, birds use natural cues such as the position of the stars and the moon to navigate. Artificial light can interfere with these natural cues, causing a variety of issues for migrating birds. Indeed, birds are frequently drawn to artificial light sources, particularly those that are bright and consistent. This can cause them to become bewildered and waste energy by circling the light source. Furthermore, light pollution can obscure natural vistas, making it difficult for them to detect navigational landmarks. This can cause them to get disoriented and lost. Finally, artificial light can interfere with birds' regular migrating behavior. Birds, for example, may be more likely to feed at night when exposed to artificial light, which can disturb their usual feeding and resting routines. This is an intriguing argument because humans experience something similar. Artificial light has a significant impact on our circadian cycles. Have you ever heard of them? Effects on human health. To put it simply, humans have internal biological clocks that control a variety of physiological functions including sleep-wake cycles, hormone production, body temperature, and cognitive performance. Circadian rhythms are clocks that are synced with the 24-hour day-night cycle. Electronic screens and LED lights, on the other hand, have been shown to disturb these cycles by decreasing the generation of melatonin, a hormone needed for sleep regulation. To counteract this, it is best to avoid using phones after 7 p.m. help increase sleep quality. Disrupted circadian rhythms can cause cognitive deficits in addition to sleep difficulties. When these rhythms are not adequately regulated, memory, concentration and decision-making abilities can suffer. Furthermore, studies have shown that continuous exposure to light pollution, as well as the disturbances in circadian cycles that ensue, can dramatically raise the risk of a variety of health disorders. Obesity, diabetes, cardiovascular disease, and some forms of cancer are among them. It is critical to recognize that light pollution is more than just obscuring our view of the night sky, it has far-reaching consequences for our entire well-being. Artificial light's harmful impact on human health should be treated carefully. We may reduce the negative impacts of light pollution on our circadian cycles and lessen the related health risks by being attentive of our exposure to electronic screens, altering our behaviors and prioritizing healthy sleep patterns. What can we do? So what can we do to make the world a darker place? The answer may be simpler than you think. We can reduce the detrimental impacts of artificial light on our environment by taking tiny daily steps. For example, cities could consider installing motion sensor lights or timers for outdoor lighting to ensure that they are only activated when needed. They could also use shielded fixtures that direct light downward, preventing it from scattering into the sky or other locations. Furthermore, warmer, amber-colored lights with lower color temperatures, about 2700 K, should be preferred over colder, bluish lights. These lights are less bothersome to wildlife and are also better for stargazing. Finally, we must be cautious of how we use indoor illumination. We may help by turning off lights in unoccupied rooms or when natural light is adequate. By adopting these easy steps, we can help to make the world a safer place for everyone. So why not begin today? What role do we play in the Milky Way? What about our place in the universe? Many people in ancient times believed that our planet Earth was at the center of the universe, as stated by Aristotle and Ptolemaeus in their Ptolemaic Aristotelic concept of universe. According to this model, Earth is at the center of the universe and all other celestial bodies orbit around it. Many people today believe the same thing. Is this, however, the case? To address this question, let us attempt to journey through space and time in the universe, beginning with our planet and ending at the universe's extreme frontiers. Galileo Galilei, the famous Italian astronomer, was one of the first people in the modern era to have some doubts about the geocentric model of the universe. Using telescopic observations, he was able to demonstrate that our Earth is not at the rotation center of planets and the Sun, but rather the Sun itself. Furthermore, when monitoring Jupiter, he realized that the massive planet serves as the rotating center for its moons. As a result, Galileo realized that the Sun, not the Earth, was the center of the solar system. The solar system is comprised of a star, the Sun, 8 planets, and many sorts of small celestial bodies such as comets, asteroids, and dwarf planets. Although the Earth is not at the center of the solar system, it may be the closest planet to our Sun. No, because it is only the third planet from the Sun. Mercury is the closest planet to our star, followed by Venus and then Earth. The Earth, like all other celestial bodies in the solar system, revolves around the Sun, our star. This means that the Sun, not our planet, is the solar system's center of rotation. The Earth takes a year, 365 days, to complete its orbit, and its average distance from the Sun is 150 million kilometers, which is the measure unit of distance in the solar system known as the astronomical unit and abbreviated AU. Because the Earth's orbit around the Sun is elliptical rather than circular, there will be an aphelion, the point of the Earth's orbit farthest from the Sun just over 1 AU away from it, and a perihelion, the point of the Earth's orbit closest to the Sun, just under 1 AU. Another way to define the astronomical unit is to say that the average distance between Earth and the Sun is equal to about 8 light minutes. This means that sunlight takes 8 minutes to arrive on Earth, so the sunlight we see at a particular moment is not that of that moment, but rather the sunlight that left the Sun 8 minutes earlier. In other words, if the Sun went out at 2:30 p.m., we would only notice it at 2:38 p.m. Alternatively, if you could go on board the Star Wars Millennium Falcon, it would only take 8 minutes to journey from the Sun to Earth, while in reality it takes several years. To put the size of the solar system into perspective, if the Sun were a 14 centimeters diameter sphere, Pluto would be 700 m from the Sun or 7 regular soccer fields. The Moon, our satellite, is the closest celestial body to Earth. To go there, you'll need 3 days off. It's the same amount of time it took Apollo astronauts to travel the almost 400,000 kilometers between the Moon and Earth. However, if you possess Star Trek Enterprise and traveled at maximum curvature, you could reach the Moon in less than 2 seconds. Let us now proceed to the outer solar system, where we will encounter the asteroid's main belt at a distance of 2 to 3 AU from the Sun, between the orbits of Mars and Jupiter. Asteroids are tiny stony bodies with diameters ranging from a few kilometers to a few hundred kilometers. They are so minuscule that they can only be seen using a telescope and not with the naked eye. With a standard spaceship or probe, we could reach asteroids in a matter of years. To fly by Pluto, one of the solar system's outermost worlds, we would need approximately 10 years and 40 AU. Consider this: if you were on Pluto's surface and looked at our planet, you would only see a pale blue dot. This is the identical view obtained in 1990 by NASA's Voyager 1 mission as it was leaving Neptune behind. Only the dark grandeur of the universe, faintly lit by starlight, surrounds Earth. We have now departed our solar system and are heading into interstellar space. We need to travel more than 4 light-years to reach Proxima Centauri, the nearest star to Earth. A light-year is the distance traveled by light in a year in a vacuum, which is approximately 10,000 billion kilometers. Distances continue to grow large, as the Millennium Falcon would take more than 4 years to reach Proxima Centauri at light speed. And what about the Sun? It's true that it's at the center of the solar system, but is it also at the center of the Milky Way? You will find it if you continue to travel in your lovely spaceship. But it's a lengthy journey, so you'll need to be patient. The Milky Way is our galaxy. It is a massive collection of stars bound together by gravity. It has the appearance of a flattened disk with a brilliant core in the center where star density is extremely high and spiral arms surrounding it. A spheroidal ring surrounds the core and extends beyond the galactic planet. At this point, it may be good to introduce the parsec, which is equivalent to 3.26 light-years, as a unit of measurement for the size of our galaxy. As a result, our Milky Way has a diameter of roughly 30,000 parsec, which is equal to 100,000 light-years. So even if we were back on the Millennium Falcon and had to span the Milky Way from one side to the other at the speed of light, the fastest thing there is, it would still take us 100,000 years. To put it another way, if you were to send a WhatsApp message to your friends on the other side of the galaxy to decide what to do for the weekend, your message would take about 100,000 years to arrive. Assuming your friends respond immediately, the response would take another 100,000 years to reach you. Using the same analogy as before, if the Sun were a 14 centimeters diameter sphere, our Milky Way would have a diameter of 100 million kilometers, which is comparable to 2,497 spins of the Earth around the equator. The galactic halo has a diameter of around 30 kiloparsec and is filled by ancient stars, which are stars that are twice as old as the Sun. Instead, younger stars such as the Sun are found within the arm of Orion, a secondary arm of the Milky Way between the arms of Perseus and Sagittarius. Our Sun is merely one of an estimated 200 billion stars in the galaxy. Because it is the galaxy par excellence, our galaxy, its name derives from the Greek galaxias, the way of milk, referring to an ancient Greek myth in which the Milky Way would represent nothing other than the milk sprinkled out of the goddess Hera's breast while nursing little Hercules. If you chance to be on a hillside on a bright summer night and look up at the sky, you will undoubtedly discover a whitish, milky band that across the entire sky, it is the Milky Way. Because the Sun is inside one of the Milky Way's spiral arms, we see the galaxy as a streak from Earth precisely because we are looking at the galactic plane edge on and from within it. It's like trying to see the entire condominium from our flat. We'll only see our neighbor's flat, not the entire condominium, because we're in it. However, is the Sun in the center of the galaxy? No, its distance from the galactic center is around 8,000 parsec, or 26,000 light-years. Our star's cycle around the galactic center takes about 250 million years, which means that since its formation, it has only made about 25 orbits around the center of our Milky Way, traveling at 215 kilometers per second. And it's a good thing the Sun isn't at the center of the galaxy, because there's a supermassive black hole there, Sagittarius A star, a monster with a mass equal to around 4.3 million times the solar mass and an enormous gravitational field so strong that even light can't escape. This massive black hole is located in the direction of the constellation Sagittarius, which is visible in the northern hemisphere during the summer and in the southern hemisphere during the winter. Because a black hole does not emit visible light, the kind we see with our eyes, it cannot be seen directly using a telescope, but it can be detected indirectly. Number 1. Radiation emitted by the accretion disk around the black hole. A black hole is surrounded by an accretion disk which is formed of matter that orbits and spirals around it. This matter eventually falls into the black hole. However, before entering it, it is heated to extremely high temperatures on the scale of 1,000,000 degrees, producing extremely high energy electromagnetic waves like as X-rays and gamma rays. Number 2. Study of the orbits of the stars closest to the black hole. When the movement of the stars in the vicinity of the galactic center was studied, it was discovered that they seemed to spin around nothing, because there was no visible celestial body in that location. Over many years, studies led by astrophysicists Andrea Ghez and Reinhard Genzel, who shared the 2020 Nobel Prize in Physics with Roger Penrose, have revealed the existence of a celestial compact body at the center of our galaxy, right in the area where the black hole Sagittarius A star is located. How about the Milky Way? Is it located at the center of the universe? Even in this situation, the answer is negative. The Milky Way is a member of the local group of galaxies with a diameter of 10 million light-years or 3.1 mpc, megaparsec. We recall that 1 mpc equals 1 million pc and 1 pc equals 3.26 light-years. The local group contains over 70 galaxies, the most of which are tiny in size. The local group center of mass is located between the Milky Way and the Andromeda Galaxy M31. The local group, along with the galaxies of the Eridanus cluster, Fornax cluster, and Virgo cluster, form the local supercluster, which has a diameter of about 110 million light-years. Our universe is expected to contain roughly 200 billion galaxies, each with 200 billion stars. Do you believe that we have only studied a small portion of the universe via satellites, space probes, and telescopes? To summarize, our Earth is not at the heart of the galaxy or the universe, but rather a little planet orbiting a small star in a peripheral zone of a spiral galaxy like many others. According to Carl Sagan, the universe is little more than a mote of dust suspended in a sunbeam. What are your thoughts? Let us know in the comments. Alright folks, that is all for this video. Thanks for watching. And if you find this content valuable, give it a thumbs up, subscribe and ring the bell so you won't miss our daily videos.